Hello, last lesson we looked at probability. So at this stage, you should feel quite comfortable with hypotheses, so alternative hypotheses and null hypotheses. You should understand the term probability and you should be able to describe p-values, significance levels, type 1, type 2 errors, etc. Today we're moving on to an introduction to statistical tests before we look at the individual parametric and non-parametric tests. So firstly, let's have a bit of a refresh of levels of measurement. So obviously these are nominal, ordinal and interval data. So what I want you to do is match the definition with the type of data. So just pause me now. Frequency count data is nominal data. So this is just where there are categories and we count the amount of times that the data fits into that category. And I'm going to talk more about that in a second. Scores in rank order is ordinal data. And I'll tell you how you can remember that. Continuous scale is interval or ratio data. So you probably have only learned about interval data at this point. I'm going to tell you what the difference between interval and ratio data is, although it won't really matter when you are choosing a statistical test. As I said on the previous slide, nominal data consist of numbers of participants falling into various categories. So these categories can be anything. It could be your A-level subjects or it can be your gender. Ordinal data can be ordered, and that's a good way to remember it because the data with ordinal data is always ranked, so from lowest to highest. For example, if there were athletes running a 100-metre race, that would be ordinal data because we would place them first, second, third, fourth, etc. But the interval between first and second and third will probably be unequal. So there's not going to be the same difference in time between the first and second athlete than the second and third athlete. Similarly, if I give you a class test, I can rank all of your scores in order, so I can tell you who came first in the class and who came last in the class, but the interval between the scores of the actual test would not be the same because some questions are harder than others, so we can't say that 1 point or 1 mark is always equal. Let's look now at the differences between interval and ratio data because there are a lot of similarities between them. Interval data has fixed intervals. So the units of measurements are fixed throughout the range, which means that the differences between the intervals are always the same. A good example of this is distance, because the difference between 1.82 metres, for example, to 1.7 metres is the same as 1.7 metres to 1.58 metres. Another example of interval data would be temperature, because the difference between 1 degree and 2 degrees is the same as 38 degrees and 39 degrees. Ratio is very similar. It's basically the same as interval data, except it has a meaningful 0 point. So, for example, time, because 0 time is a thing. You can think of it as interval data can go into minuses, so temperature and distance. However, things like time cannot. The similarities between interval and ratio data are so great that they are sometimes combined to form interval ratio data. Sometimes ratio isn't even mentioned and it will just say interval data. I know you've done this before, but I want you to try and think back. So you might not be able to see this. Here we have the calories of each sweet treat. So how could we demonstrate levels of measurement using this picture? So what could we do to put this data into nominal? How could we place it into ordinal data? And how could we place it into interval data or ratio data? In terms of nominal data, we could place the cakes into fruit tarts, donuts, cupcakes, and biscuits, because nominal data is just categories and we count the frequency that each of these occur. Ordinal data, we could rank them in order of preference. So you could say your number 1 choice to your number 12 choice, because it's order, but it's not telling us anything else about the data. And then interval and ratio data, remember, has to have fixed intervals, the same difference between data. So we could do an interval scale based on estimated calories, or you might have also said price, because the difference from 1 penny to 2 pennies is the same as 5 pennies to 6 pennies. Just one last thing on levels of measurement. I just want you to get really comfortable with it, because identifying the level of measurement used by a research study is really important to be able to identify the statistical test that we need. So I want you to look at these examples and tell me whether the data is nominal, ordinal, or interval. And a good way to do this is to start with nominal. So look at the data and say, okay, could I put this into categories? If the answer is no, then check if it's ordinal. Could I rank this? And if the answer is again no, then you know that it's interval. So pause me now and have a go. Heart rate in newborn babies would be interval or ratio data. Specifically, it would be ratio because it has an absolute 0. You can't have a minus heart rate. How many people in a class would vote for each of the main political parties? This is nominal because we would just put the political parties as the categories and we would do a frequency count of how many people fit into each of those parties. Ratings of how happy each student feels about their psychology score. Is it nominal? No, because it's not categorised, therefore it's ordinal. And we could rank it from the happiest student to the least happiest student. The time taken for participants to complete a questionnaire, that is interval. Patients' ratings of satisfaction with the service of their dentist, that again is ordinal. It's not categorised and the difference between ratings isn't equal. The number of calories consumed by a participant on each day, interval data, because the difference from, say, 22 calories is the same, 22 calories to 23 calories is the same as 24 to 25 calories. How many boys and girls each choose to do an apprenticeship or a degree? That is nominal data because we would just place apprenticeship, degree, then do a frequency count. Favourite foods of a group of nurses, again, is nominal because we would just put all the favourite foods and then do a frequency count. A study of the main mode of transport to school of year 7. Again, that is nominal. We would categorise the modes of transport, count how many times that occurs. And finally, the weight of participants beginning a diet study. That would be interval data, while specifically would be ratio data, because again, you can't be a minus weight. Statistical test. I think you should already know that there are 2 kinds of statistics. There are descriptive statistics, such as averages and graphs, and then there are inferential statistics. And we briefly discussed these in the probability lesson. Inferential statistics are designed by statisticians who work out probabilities of certain results so we can decide whether to reject or accept the null hypothesis. And being able to decide whether we can accept or reject the null hypothesis is key to answering any question about statistical tests correctly. They're called inferential because we make inferences about a whole population based on a small sample. It's impossible to test a whole population. So we do a smaller sample, and if the results are significant and the difference between the results are big enough, then we can assume that the same is true for the whole population. We may find a difference of correlation in our sample, but it's this idea of finding out if the difference is big enough in order to be able to make an inference about the entire population. And we use inferential test to test whether the result is significant using tables of critical values. And we're going to look more at critical values today, but we have already done this when we looked at how we complete a sign test. And just as a reminder, the sign test is the only one you will be asked to calculate in an exam. In the next few lessons, we're going to look in a lot of detail at the differences between parametric and non-parametric tests. In order for a test to be parametric, it needs to meet certain criteria, which we're going to look at in the next few slides. Parametric tests are always preferred by psychologists because they are more powerful. And what we mean by the word powerful is that they use the mean and the standard deviation of a data set, whereas non-parametric tests only use ranked data, which means we can see the order that the data's gone in, but it loses some of the detail because we don't know anything else about it. Which also means that parametric tests can detect a significance in some situations where non-parametric tests can't. So if you look at this flowchart I've just said, it needs to meet certain criteria. So if it meets that criteria, then great. The next question we have to ask ourselves is, okay, is it a correlation? If it is, then that's Pearson's R. If it's not a correlation, you need to ask yourselves, is it a test of difference? So are we looking at the differences between two data sets? Yes, is it repeated measures, or is it independent groups? And I'm going to show you a better way that you've probably seen before of choosing a statistical test, one that's easier to remember than this flowchart. But if it's non-parametric and then we're looking at nominal data, then we still have to ask ourselves, what kind of experimental design did they use? So you should be able to, when you look at an exam question, to identify whether it was in independent groups, repeated measures, or matched pairs. Matched pairs still counts as repeated measures because the data set are similar or they're related. And if it's ordinal data, again, we have to ask ourselves, is it correlation? If it is, we go a different way. If it's not, we have to identify the experimental design. This is an easier way to remember which statistical test to use, and you will have to memorise this. So this is the mnemonic that I use. Simon Cowell wants more singers receiving unanimous praise. You might think of a better mnemonic that works for you. But what's important to detect here is we need to know whether it's a test of difference or a test of association. Association means that we're looking for a relationship between variables. So are we looking for a relationship or are we looking for a difference between the data sets? If we're looking for a data set, then we have to ask ourselves, was it a related design? So was it matched pairs or repeated measures? Or was it an unrelated design? Was it independent groups? Which means that the two groups aren't related in any way. And most importantly, we have to be able to identify the level of measurement. If it's nominal, we're using the sign test or the chi-squared. Ordinal, Wilcoxon, Mount Whitney, Spearman's Rho. Interval data, we're using related t-test, unrelated t-test, Pearson's R. Remember, ratio fits into this category also. Let's look now at the parametric criteria. There are 3 criteria that needs to meet in order for us to be able to conduct a parametric test. The first one is the level of measurement, and we've looked at this in a lot of detail this lesson, so I'm not going to go on about it anymore. But if it is nominal or ordinal, so ordered in some way, then we're going to use a non-parametric test. If it's interval or ratio data, then we can use parametric. The next one is that the data has to be normally distributed, and this is something that we have looked at before. So it's not the sample that has to be normally distributed, it's the data from the whole population that has to be normally distributed. So in other words, the behaviour or the thing that we're investigating has to be normal. And with normal distribution, it means that most items cluster around the mean with an equal number of items below and above the mean, and the mode and median are in the middle as well. We expect things like height, shoe size, IQ, etc. to be normally distributed because there are people with really, really high IQ, people with really low IQ, but most people will fall somewhere in the middle. So before we justify the use of a parametric test, we can test whether our data is normally distributed, negatively or positively distributed. So if you remember this, negatively skewed data, it means that the mean is to the left. We remember that because left has an E in it, negative also has an E in it. So the mean is to the left of the median and the mode, which means it is lower than the median and the mode. And then with positively skewed data, we remember it because it has an I. Yes, negative also has an I in it, I know, but that's just the way I remember it. And that means that the mean is higher. It's to the right of the mode and the median. And the last one is that the variances of the two samples are not significantly different. What does this mean? It means that the set of data is spread out quite equally around the mean. And how we work out the variance is we look at the square of the standard deviation. So with repeated measures or matched pairs, any difference in the variances will not distort the results. We only need to check the variance for independent groups design. So the variance of one sample should not be more than 4 times the variance of the other. For the last bit of the lesson, we're going to look at how we actually use the statistical test to find the results of our study. So with calculated and critical values, every statistical test, the only one you will have to compute is the sign test, but always involves taking the data collected and doing some sort of calculation to produce the test statistic. And each different statistical test has a different letter. So for example, with the sign test, the calculated value that we find is called S. And so whatever we calculate is called the calculated value. And that's how you can remember that. To decide if this value, this calculated value, is significant, we have to compare it with the critical value. And you will always be provided with a critical value table. So you'll never have to memorise the critical values. There are different statistical tables for each different statistical test. To find the appropriate critical value in the table, you need to know, number one, the significance level. If the exam question doesn't state it, then you can assume that P is less than or equal to 0.05. If it states it, it might be 0.1 or 0.01. We have to know the kind of hypothesis, and this won't always be stated to you. You might have to work this out. So if it's a one-tailed, it means it's directional, it's telling us which way the results are going to go. If it's two-tailed, it's going to be non-directional, so it's not going to tell us which way the data is going to go, but it'll tell us that there will be a significant. It'll tell us that there will be a difference between the two data sets. And then we have to know the value of n, and this is just the total number of participants. With independent groups design, we'll have two groups, NA and NB, and you'll have to compare the critical value and the calculated value in each of those n's. With sum t-test and chi-squared, you have to calculate degrees of freedom. You will never be asked to calculate degrees of freedom in an exam, but degrees of freedom will be present in the critical values table. One way to remember whether the critical value needs to be less than or greater than the calculated value is with the letter R. This will always be made clear to you. Underneath the critical values table, it will always say the critical value needs to be either greater than or less than the calculated value. But one way to remember it is that if there is an R in the name of the test, then the calculated value should be greater. If there is no R, then the calculated value should be less than the critical value. So have a look at this table, and for example, In chi-squared, there's the R. In Spearman's row, there's the R. Pearson's R. Unrelated t-test and related t-test all have R's. Then the calculated value should be greater than the critical value. I want you to complete an exam question, and it is tricky. So I'm going to talk you through it, and I want you to give it your best go, and then I will upload the mark scheme before your next research methods lesson. The first question is the most straightforward one. It just asks you to write a non-directional hypothesis for the study. So read the description first, and then give me a non-directional hypothesis. Remember, so you're telling me that there is going to be a difference, but you're not telling me which way it's going to go. And remember to mention both of the IVs and the DV operationalised. Number 2, it asks you to identify an appropriate sampling method for this study and explain how the psychologist might have obtained such a sample. So this is a fairly straightforward question also. It doesn't really matter which which sampling technique you use. You can use volunteer, opportunity, whatever, but just make sure you describe it accurately and relate it to this specific scenario. Tell me specifically how the psychologist is going to obtain that sample, because it's a 3-mark question, so it has to be specific. And then this next bit is worth 12 marks. So you're going to be asked to complete a few things. The first one is to draw a contingency table. Contingency table is just going to tell me the frequency, and it'll become clear when you read the question, but basically it's to do with the participants. So I want you to tell me how many of each participants in each category there was. And then you need to sketch me an appropriately labelled bar chart. If the bar chart doesn't have labels on the X and the Y axis, it actually gains 0 marks. It also has to have a title. And the bar chart is just, again, telling me the frequency of each of the 2 categories. Identification of the appropriate statistical test with justification for its use. So have a look at the Simon-Cowell table and tell me which statistical test we're going to use and why. So say what kind of level of measurement it's using, what is the experimental design. Identification of an appropriate significance level. Remember, if it doesn't state the p-value, then it's going to be p is less than or equal to 0.05. And the last one is a statement of the results of the statistical test in relation to the hypothesis. So your job will be to look at the critical value, tell me if it needs to be, depending on the test you've used, does it have to be greater than or less than the calculated value, and tell me if the results are significant, and then tell me which hypothesis we're accepting or which one we're rejecting. Okay, any questions, let me know. I've attached the exam question onto Teams with this lesson. Let me know if there were any questions.